Welcome. Today we are going to be looking at solving quadratics with radicals. So today what we're doing is we're taking the idea that we've been looking at quadratics. We learned how to graph them. We learned how to graph them in a few different ways. And then we're taking the idea of the radicals that we learned how to simplify, add, subtract. We are going to kind of bring those together. We're going to be solving equations now that are quadratic, so quadratic equations, and there's a few different ways we can do that, one being radicals. So when we look at our essential question today, we're essentially looking at that beginning. We learned how to graph this first, this ax squared plus c equals 0. So we learned how to graph this and how that changed our vertex and how that might stretch our graph with the a and whatnot. But now we're setting it equal to 0 or equal to something. So we're making it an equation and we want to learn how to solve this. Well, we can use the idea of radicals to solve this. And what we're going to do is use the square root to be able to find our missing x value. And something I'm going to show you is that with every quadratic, okay, we have maybe a different number of solutions. We could potentially have two solutions because if you remember, we generally, when we would factor something like this, okay, we would generally end up with two different types of solutions. Or we could end up with one solution, and there's one case where that will be the case. Or we could end up with no solution. So we're going to talk about all of those. So this slide would be important to write down or at least know where it's at in your journal. So when we are working and we have an equation with a squared term, so making it a quadratic, if d over here is greater than 0, x is going to equal the square root of d, and it could be plus or minus. So there's going to be two answers. So I'm going to give you a quick example of that here. So x squared equals 36. Something pretty simple. So to solve this, we would get x alone by taking the square root, because something squared and the square root, they are inverses of each other. They cancel each other out. I have x left. So I'm gonna, whatever I do to one side, I have to do to the other. So the square root of 36 is, yes, indeed, 6, but we have to consider plus or minus. Because look at this. If you think about this, if we had x squared equals 36, if we had positive 6 squared, that would be 36. If we had negative 6 squared, that would also be 36. So you can kind of check your answers that way. So whenever this piece over here is positive, you're going to have two answers, plus and minus. Now, when d equals 0, so for instance, x squared equals 0, we're going to have one solution, and all it's going to be is 0. The square root of 0, well, what times itself gives you 0? Well, that's going to be 0. And then when we have d being less than 0, so essentially negative, there's no real solutions. And we talked about this before. So if we had something that looked like this, okay, if we found the square root, or if we wanted to square root that, remember there is absolutely nothing, no number we can get that's going to, when we multiply it by itself, give us a negative number. So the answer to this would be no solution, because there's no number that's going to be multiplied by itself that will give you a negative number. So these are very important. We're going to use these in a lot of examples today, but I think you guys will catch on pretty quickly to the idea of solving these quadratic equations. All right, so here's a quadratic equation. We have a squared term, and our goal is to get x squared alone. That's what we want to do, because then we're able to work with our radicals to get x alone. So if I want to get x squared alone, my first step would be to add 27 to both sides. So I have 3x squared equals 27. If I'm still working to get x squared alone, I'm going to divide by 3. So what I end up with is x squared equals 9. All right, so now we're at a point where we want to solve this quadratic equation, we're going to take the square root. So x, now remember, we're going to have two answers here because this is greater than 0, is going to be plus or minus 3. I'm going to show you another example of another way to do this that you would also see that you're going to get two answers. What if we factored this first one? Okay, so if I factored out a 3, I'd have x squared minus 9 equals 0. Then I would divide by 3. Well, 0 divided by 3 is just 0. So x squared minus 9 equals 0. And now, add 9. Well, I could even factor this further. I don't even need to do that. Factor again. So I'd have x plus 3 times x minus 3 gives me 0. So now if I set each of these equal to 0, miraculously, what would I get? X equals 3 and x equals negative 3. So it's just more proof that that works. Okay, so let's look at B. We have x squared minus 10 equals negative 10. So I'm going to add 10 to both sides to get x squared alone, and I get 0. So if x squared equals 0, if I find the square root of 0, x is just going to be 0. Okay, last one on this slide. If I subtract 11 here, I get negative 5 x squared equals 5. If I divide by negative 5 to get x squared alone, I would get negative 1. So can this happen? Can we have negative 1 under a radical symbol? We cannot. So the answer to this one would be no solution. Okay. Let's look here. So this looks a little different. We have a quantity of x minus 1 squared equals 25. Okay, so now we don't have an x squared that we're trying to get alone. We have an x that we're trying to get alone. So we need to do it ahead of time. We need to take the square root of this whole piece and this whole piece. So if we're going to do something to one side, we have to do it to the other. So then my square root and my squared cancel, so I'm left with x minus 1. But the square root of 25, we have to remember, is plus or minus 5. It can be both. So now we have to work through that idea, because now I want to get x alone. I'm going to add 1 to both sides. So I have two options. I have x plus 5 and x equals, 1 plus 5 and 1 minus 5. Okay, so this would be 6 and this would be negative 4. So you can go back and check to see if this would actually work if you don't believe me. Okay, so we're going to plug it into the original problem. 6 minus 1 squared is going to give me 25. So that would be 5 squared equals 25, which is true. And negative 4 minus 1 squared should give me 25. So negative 5 squared does in fact give me 25. So C here, we had to make sure that we had both options because there's going to be two options there when we're working with the quadratic. All right, we have some more examples. There's plenty of examples on this slide. We probably won't do them all. So number one, we want to get x squared by itself. I'm going to divide by negative 3. So I have x squared equals 25. Now I'm going to take the square root. So I have x equals plus or minus 5. Number 2, I'm going to subtract 12 from both sides to get x squared alone. So I end up with negative 2. We cannot have a negative under the radical, so we end up with no solution. I'm going to jump down here to number 4 and 5. So here, this is where we need to do the square root right off the bat. So we'd have x plus 7 equals, well, the square root of 0 is just 0. Okay, so we might not have two answers on this one. So we're going to subtract 7. So x equals negative 7. You can check that. Negative 7 plus 7 is 0. 0 squared is, in fact, 0. So that in that case, we only have one answer. Okay, number 5 is important to look at here. So in this case, we want to get x minus 3 squared by itself. So I'm going to divide the whole thing by 4, so to get rid of that 4. So what I end up with is x minus 3 squared equals 9/4. Okay, then we would take the square root here, because we got to get that by itself. So x minus 3 is going to equal, now the square root of 9 is 3 and the square root of 4 is 2, so we'd have plus or minus 3/2. So from there, okay, I'm going to add 3 to this side, but then again I have those two options. So I'm going to have 3 plus 3/2 and 3 minus 3/2. So I may need to find a common denominator, which would be 6/2 plus 3/2 and 6/2 minus 3/2. So our x's end up being x equals, in this case, 9/2 and x equals 3/2. Okay, so some fractions in that one. Remember, if you have any questions as I'm going through these on the video, you could always raise your hand and I can come around and kind of work through something with you there. I'm going to skip that slide in a moment. And that one. Okay, I'm going to get you going on the homework just because I want you to get started so you can get any questions answered on either yesterday's assignment or today's, because I know I wasn't there to answer any questions. So today's assignment is page 289 in your journal. It's numbers 1 through 15. So you're just practicing solving using radicals. I want to kind of let you know, moving forward, we are going to be solving quadratic equations in different ways. So we're going to look at it with radicals. We're going to complete the square, which we'll talk about next week, and we will look at the quadratic formula, which we'll look at next week. So those are kind of what's upcoming. We're going to be working a lot with solving those quadratic equations, and which will lead into, you know, you've already learned how to solve linear equations, so this is good to also know how to solve quadratics. And as I've said before, you will use a lot of this radical information in geometry next year. So these are all good things. So make sure if you have questions over anything, you come and see me. I know this is a little bit different than we have been doing, but I want to keep trying it and keep seeing how it's going. So make sure you ask lots of questions if you need. And otherwise, have a great weekend, and we will see you on Monday.